For question 5, we're asked to solve each equation for the given variable. A thing that I didn't notice is I believe all of these have solutions today. So there was none of the case where this was problems with no solution or problem with infinitely many solutions. It turns out that these, I think, just had just a single solution in each case. So let's go ahead and take a look at them. Part A first. To solve this, I'm going to take away 1 from each side. So again, this right here is my equation. There's an equal sign here. Things have to stay in balance. And if I do something to the left-hand side, highlighted in yellow, right, I have to do the same thing to the right-hand side, highlighted in green. So you can see on each side I'm adding 1. And when I add 1 to my my left-hand side rather, it just becomes simply 2x, right? Because you can see this positive 1 and negative 1 just makes the number 0. Now, why can I add 1 or subtract 1 from both sides? Well, because I'm doing it to both sides. And anytime I have things that are equal, if I take away the same value from each side, I get things that are equal. So by subtracting 1 from both sides, you can see I get 2x. From the other side, I get 10. And now I'm going to divide both sides by 2. And again, if you have things that are equal and you divide both sides by the same value that's non-zero, you get things that are equal. So on my left-hand side, you can see there's a giant 1 there. So I have just x equals 10 over 2, which is simply 5. So when x is 5, I have my solution. Now, many of you are looking at problems like this and you're saying, you know what that is? That's what I call 5. And you see that and then you show me you're checking that, right? You're plugging it in and checking it. That's not actually using algebra yet, right? It's not solving an equation, right? And I'm asking you to solve this equation. This process of solving an equation involves these techniques, right? Adding, subtracting, multiplying, dividing both sides by the same value. Replacing things, distributive properties. So anyways, I'm looking for this technique. I'm looking for evidence of this algebra, not simply the fact that you guessed, oh, I think it's 5, and then you show me, oh, 2 times 2 times 5 is 10, plus 1 is 11. Hey, I got it. Yeah, that's great, and it's good that you check it like that, but look at the algebra techniques, because I think many of you see this and know it. These quickly get to where they're difficult to deal with unless you know these techniques and you're proficient with them. So let's keep practicing algebra. And this next problem, I'm going to use the distributive property over on the left-hand side. So I'm just rewriting the left-hand side. This is the same as 6 times x and then minus the number 30. And again, if I have some difference between two numbers and the difference is being multiplied by 6, I can distribute that 6 across that subtraction problem. So these are equivalent to each other. And I encourage you to play with some numbers and see if you believe that, right? It's nice to verify these things numerically with some concrete examples. Over on the left-hand side, I'm just going to rewrite the 4x plus 10. I think I'm going to go ahead and take away 4x from both sides. So I have 10 is equal to 2x. Again, I'm subtracting 4x's from each side. When I subtract 4x's from the left-hand side, these are gone. And from the right-hand side, this 6x will become 2x and then minus 30. And then I'm going to add 30 to both sides. So this side will become just simply 2x because I've added 30 to cancel out this minus 30. And then I'm going to add 30 over here and I get the number 40. And if I divide both sides by 2, you can see that I get 20 is apparently what x is. So x is the number 20 for B. X is 20. And I encourage you to, when you're looking at these, hit pause and take a look at it and consider the things I'm saying, consider what you're seeing here, and just kind of let it wash over and become what you're doing. You don't have to watch this, quickly once. You can watch it as often as you need to until you can master these techniques. Let's take a look at part C. In C, I'm going to kind of introduce this now. This is kind of a technique that I think we've talked about in class, but not a lot. What I'm going to do is I'm going to multiply both sides of this equation by the number 8. And I'll make it look like 8 over 1 on both sides. Forget this C, it's not here. Well, The reason why I chose that is I know that if I multiply both sides by 8, if you look at the left-hand side, it's a 2 times an x times an 8 over, it's a 1 times an 8. So this 8 cancels, or not, sorry, this 8 becomes a giant 1, this 8 over 8. So what I'm left with on the left-hand side is just 2x. And so that was my motivation. If you're wondering, well, why did he pick 8? It's because I wanted this 8 that I was dividing by to go away, to cease to exist. Now, over on the left hand side, this is simply 8 times 10, which is the number 80. And if I divide both sides of this by 2, you can see that I get that 40, right? X is 40. X is 40. And it's nice, to come back in and verify that, right? 2 times 40 is 80, and 80 divided by 8 is indeed 10. So it works rather nicely. And you can see the steps there that I used. So more about this later. We'll talk more about it. Our textbook calls this fraction busters. This is maybe baby fraction busters tonight. We're not doing a lot of it, but there's a bit of it there. The last problem, most of you seem to do this pretty well. There is some problems with the distributive property, but I'll go ahead and add the 2x plus 1, and then plus 4x, and then minus 8, and then that will equal 11 on the other side. It's interesting, I did see this several times. Several of you looked at this positive 1 and negative 8, and believe it or not, you wrote down below that this became a positive 7. And it doesn't, right? 2x plus 4x, there's 6 of the x's, and then a positive 1 and a negative 8, when I add them, combine them with addition, would become negative 7, and that equals 11. If I add 7 to both sides, we have that 6 times x equals 18. And then finally, I could divide both sides of this by 6, and I get that x has to be the number 3. So x is 3, and if I check it by plugging in 3 here and 3 here, I should get 11 on this side. If I look at this, 2 times 3 is just the number 6. So I've got a 6 plus a 1. And then over here I've got this 3 minus, I'm sorry, 3 minus 2, which is 1. So this becomes nothing more than plus 4 times a 1, which is just 4. So you can see I've got 6 and 1 is the number 7, and 7 plus 4 is 11. Probably better is, 6 and 4 is 10, and 10 plus 1 is 11. But at any rate, this is the algebra that justifies the answer. And then up above, you can see some quick arithmetic that's checking that this value does indeed work. So x is the number 3, and that's our solution for part D.